Hello dears, welcome to my channel Maths for You by Attaur Rahman. In this lecture, we are taking up grade 9 mathematics, unit 15. Today I have brought one of the most famous theorem in mathematics, that is the Pythagorean theorem, named for the ancient Greek mathematician Pythagoras around 500 BC. This theorem can be used to find information about the length of the sides of a right angled triangle and the area related to them. Keep in mind that the Pythagorean theorem is applicable in a triangle called the right angled triangle. That is, a triangle in which one of the angle is a right angle. By right angle, we mean that its value is always equal to 90 degree. As we all know that the side opposite to the right angle is called the hypotenuse, while the two sides adjacent to the right angle are called the legs of the right angle triangle. It is customary to denote the length of the side opposite to the vertex A by small a. The length of the side opposite to the vertex B by small b, and the length of the side opposite to the vertex C by small c. Definition of similar triangles. Two triangles are said to be similar if all the angles of one triangle are congruent to all the angles of the second triangle. The Pythagoras Theorem. Now coming to the statement of the Pythagoras Theorem. In a right angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the other two sides. Given. Suppose we have given a right angled triangle ABC in which the angle B is a right angle. Now let us denote the length of the side BC by A, the length of the side CA by B, and the length of the side AB by C, respectively. To prove, we need to prove that B square is equal to A square plus C square. Construction. Let us do some constructions in the figure. First, we draw a perpendicular BD on the side AC, and let measurement of BD is equal to H. Further, let measurement of CD is equal to X. Therefore, it is quite obvious from the figure that measurement of AD will equal to B minus X, and label the angles as shown in the figure. Proof. First of all, I would like to draw a line so that we can separate the statements and the reasons. In statements, we will provide the assertions, the claims, while in the reasons, we will provide solid grounds for those assertions. So first, we take the correspondence of triangle ABC with triangle BDC. In both triangles, we see that angle ABC and angle 1 are congruent because they are right angles. Angle C is congruent to angle C because they are self-congruent or common in both the triangles. Also, angle 3 is congruent to angle 5. The reason for this is they are the complement of angle C. Therefore, triangle ABC is similar to triangle BDC by the definition of similar triangles. As we know that if the triangles are similar, then their sides will be proportional. Hence, we can write that B divided by A is equal to A divided by X. The reason is that they are the corresponding sides of similar triangles. So simplifying, we have Bx is equal to A square. Suppose this is our first equation. Now again consider the correspondence of triangle ABC with triangle ADB. Here we see that angle ABC is congruent to angle 2. The reason is both are right angles. Also, angle A is congruent to angle A. They are self-congruent or common to both the triangles. And angle 4 is congruent to angle 6 because they are the complement of the angle A. Therefore, by the definition of similar triangles, we can write that triangle ABC is similar to triangle ADB. And hence, we know that if the triangles are similar, then the length of their sides will be proportional. Hence, we can write B divided by C is equal to C divided by B minus X. The reason for this is because they are the corresponding sides of the similar triangle. Or simplifying this, we get B into B minus X is equal to C square. Or we can write B square minus BX is equal to C square. Mark this as the second equation. Now we have B square minus BX plus BX is equal to C square plus A square. The reason is by adding 1 and 2. Or Bx cancel with Bx, so we left with B square is equal to C square plus A square. And this is what? The proof of the Pythagorean theorem, that is, chord arrayed